Yeah, does anyone know who this character is? Because it's one of the enemies of Doctor Who, and I realized that I didn't know, Peter doesn't know, so just wondering. What's that? Ood. So yeah, anyhow, so welcome to my talk on sort of the microservice architecture. And what I'm going to be describing today is a pattern language, a collection of patterns that can help you first decide whether the microservice architecture is a good fit for your application, and then if it is, how to apply the microservice architecture in the most effective way. Because as you're going to see, it's like, yeah, I'm going to use microservices, but that has a whole lot of consequences. There's a very large number of design decisions that you then have to make. And so the patterns provide solutions to those design problems and let you make the appropriate trade-offs. So before I talk about that, a little bit about me. So I live in Oakland, just across the bay from San Francisco. Got my start in programming back in the mid to late 80s. So I've sort of been doing this for a while. Started off building Lisp systems, everything from runtimes, compilers, all the way up the stack to IDEs and the like. Eventually ended up programming in Java, wrote the book Pojos in Action, which came out 10 years ago, back when Spring was really revolutionizing how we did enterprise Java development. Way better than EJB2, for instance. And then back in 2000, sort of actually 8, I started tinkering around with this very obscure service known as Amazon EC2. This was back when Amazon was better known for being a bookseller. Totally blew my mind that they had APIs for provisioning servers. You could provision up to 20 servers and pay 10 cents an hour, which was just incredible. So much so that I created what became the original Cloud Foundry, so a PaaS for deploying Java applications on EC2. And then, of course, that got acquired by SpringSource, which is, that's where the name of this new Cloud Foundry thing came from. SpringSource was acquired by VMware, got ejected out into Pivotal, remained there for a brief amount of time. And so for the past 3-4 years now, I've been basically focusing on the microservice architecture. So I do consulting and training around the microservice architecture. And yes, I do code. I really do. So I actually have a startup, and we're creating a platform for simplifying the development of sort of transactional business applications that use the microservice architecture, dealing with data consistency and querying and so on. And I'm also writing a book on the microservice architecture as well, which is available in meat form. So that's me. Here's the agenda. So like, why microservices? Talk about the benefits, talk about the complexity and the drawbacks of the microservice architecture. They're really not a silver bullet. And I'm going to spend a lot of time talking about the pattern language, providing an overview and describing how to apply it and talking about the kinds of problems that it solves. So let's get going. So if you think about modern software development today, it's all about basically moving fast and not breaking things. And there's this really fascinating chart from the DevOps survey. And you can see that sort of high performers, the companies who are employing state-of-the-art development techniques, are doing things like deploying many times a day into production. The amount of time it takes from when a developer commits their changes to when those changes are in production are less than an hour. Netflix have a statistic where it can take up to just 15 minutes for someone to commit and then for that code to be deployed on their servers around the world. And they tend to have better availability, fewer errors. For instance, Netflix deploying every 11 seconds, I think it is. Sorry, Amazon deploying every 11 seconds, and it's only 0.001% of their builds or deployments that actually break. So, forget about sort of moving fast and breaking things. It really is moving fast and not breaking things. So the question is, how do they do this? And it turns out that it's really a combination of the right processes, specifically DevOps, continuous deployment, continuous delivery, the right organizational structure, small autonomous teams. But then there's this question about architecture, because architecture is sort of a key enabler of those other things. So if we look at sort of the standard way of building enterprise applications, it's something like this, right? Where you've got a logically layered and modular system. So in the case of this online store, you've got a presentation tier, storefront UI, web app, or REST API. Then you have various business and data access modules. So, each one representing a different business function, catalog, recommendations, reviews, orders, and so on. So we've got this nice structure, but then when it comes to deploying the application, we package it up as a single WAR file, or heaven forbid, an EAR file, and run it on some kind of server. And that's pretty much sort of the default architecture. But what's interesting about this, it's not necessarily an anti-pattern, because at least when you start, applications like this tend to be simple to develop, test, deploy, and scale. And you can actually, in the beginning, deploy many times a day. And it just generally works well. But the problem that you have, which I'm sure almost everyone in this room has encountered, is that successful applications have a habit of growing. We don't just stop development and do this thing called maintenance. Go read a classic book on software development. Apparently there's this maintenance phase, right? Turns out that development is this ongoing activity, and the more successful the application is, the larger the team is, and so the rate of change, the rate of growth actually increases as well. And the problem that you run into is that it's very likely at some point modularity will break down, and you will end up with just this big ball of mud. So layers and modules just sort of degenerate, and you end up with a code base that is a squalid, sprawling slum. And at that point, any notion of agility, it just sort of flies out of the window. So everything about developing and deploying and testing is incredibly slow and painful. And to make matters worse, you're very likely, this is another attribute of monolithic hell, you're very likely to be just tied to the technology stack that you started with at the beginning of the project. So you're sort of using this obsolete technology. So you're in a very, very painful place. So what can you do about it? So, that's where the microservice architecture comes in. So I got a few words on this slide, but it's an architectural style that structures an application as a set of services which are loosely coupled. That's really loose coupling is really important because it enables independent development, testing, and deployment. And then those services are organized around business capabilities. So each service implements a business function. And it's all about tackling complexity through modularization. It's just that in this case, our modules are not packages, but our modules are actually these services with an impermeable boundary, right? Some form of remoting API, whether that's RPC or messaging. And yeah, it might improve scalability as well. I think a common misconception with the microservice architecture is that it's all about scalability. And that's because companies like Amazon kind of adopted, or eBay adopted this microservice architecture before it was called microservices, and they happened to be web scale companies. But it was really the fact that they were in these hyper-competitive business segments where they needed to build better software faster in order to compete successfully. So it really is about tackling complexity and not dealing with scale. Monoliths can actually scale quite well. So if we again look at a microservice version of this online store, it's going to have a bunch of services corresponding to business functions. Each service will have its own private data store, not necessarily its own private database server, so you don't need to go buy a lot of Oracle licenses, but they have their own private schemas, for example. And the front end can consist of a set of functionally decomposed web applications as well. So one for browsing and searching, one for viewing the product detail page, another one for account management, checkout, and so on. And then if you're exposing an API to the outside world, you'd have an API gateway that acts as a facade and could be accessed by mobile clients or by JavaScript running in the browser. So, gosh, that's a really complex picture, right? But that sort of illustrates one of the downsides of the microservice architecture that I'm going to talk about in a minute. So that's sort of the essence of the microservice architecture. So let's look at the benefits. Why on earth would you want to do this? Well, it turns out that, going back to this sort of triangle showing what you need in order to develop software faster without breaking things, right? So the microservice architecture directly enables this because the architecture gives you much better testability and much better deployability. So the individual services can be tested in isolation and they can be deployed independently from one another. And testability and deployability is sort of one of the things that your architecture has to support if you want to do continuous delivery and deployment. So if your application's large and complex, it's very likely that you're going to have to use the microservice architecture. And likewise, the microservice architecture enables these small autonomous teams to work effectively, right? Each team owns their own service, and they can develop, test, and deploy it independently of any other services. Obviously, they have to agree on APIs and so on. But once the APIs are defined, you can go off and go your own separate way and develop in parallel with all of these other teams. And that's a direct consequence of the microservice architecture. If everyone's contributing to the monolithic code base, then there's huge amounts of communication and coordination required. And it really slows you down. So it's all about enabling the continuous delivery and deployment of large, complex applications. So this, sort of related to that, the services themselves, from the perspective of a developer who's working on their service is easier to understand, develop, and test. Its dependencies are inherently smaller, so less potential for version collisions. So you don't need something like OSGI. That's kind of one of the big motivations for OSGI. The services themselves are actually faster to build, to test, and deploy. The startup time is significantly less. They can just start up within a few seconds, and so that significantly reduces your mean time to recover, which improves your availability. As I said, it helps you organize around small autonomous teams. A team owns their service. If that service is not functioning, you know whose responsibility it is to fix it. Versus a monolith, everyone's responsible, which means that in some ways no particular person really is. And yeah, sometimes it can improve scalability. That's secondary. It can improve fault isolation. Because say a memory leak in one service is going to just impact that service, and any other services that depend on it maybe, whereas a memory leak in a monolithic application is going to impact everybody. And then this is really important. The microservice architecture enables you to much more easily evolve your technology stack. And yeah, we all love Spring, right? But every so often we're tempted to sort of turn to the dark side and use something like Golang, right? Because Google uses it, so Golang must be really cool. So you can go try it. I don't recommend it. actually am regularly reviewing Golang code, and oh my God, no exceptions? That's just ridiculous. But you can try it in this arc, as misguided as it is. You can actually try it. And eventually, when you find out that it's really just a 1990s version of C, it's not a disaster, right? You've just built this one service with it, and you can just know that, yeah, I'm going to replace this service at some point with a language that's more appropriate for the 21st century. But this is really, joking aside, this is really powerful, right? You think today people are running legacy applications that were written back in the 60s using like customized IBM assembler, and the people who understand that have literally died, right? Whereas now you can actually, that's a mark of a successful application, to have one that actually outlives you. But in reality, this lets you incrementally replace and evolve your technology stack over time, which is really, really important. Okay, so anyway, microservices are awesome, except that they're not. Or at least it's much more complicated than that. So back in 1985, famous computer scientist Fred Brooks, author of The Mythical Man Month, fascinating book, by the way. I think it was written back in 1975, and it's remarkable how little software development has changed since then. And anyway, he gave this talk saying no silver bullet. So in other words, in software engineering, there isn't anything that is perfect. It's nothing, everything basically has downsides. And by far, as I hinted at a minute ago, a significant downside of the microservice architecture is a different form of complexity, right? And it's fundamentally due to the fact that, you are building a distributed system. Whereas before, when you invoked a method, invoked another module, that was just a regular method call. Now it involves RPC or some form of messaging. And that is just, despite the fact that there are frameworks that make that relatively straightforward, there is this inherent complexity. You have to deal with things like partial failure. The service you're invoking might not respond anytime soon. And so you need to time out. That's what the circuit breaker pattern is for. So it just adds complexity. Also, the fact that you have decomposed your database creates a whole lot of complexity around managing transactions, around maintaining data consistency. You can't just begin a transaction, update whatever you want, and commit, and have all of the properties of ACID transactions. You have to use an approach known as sagas, which is a series of local transactions around these different services in order to maintain data consistency. There are frameworks that make that easier, but it's more complicated still. Likewise, queries are more complicated. You just can't do a select from, or join across orders and customers, because those are in different services. So you either have to query via APIs, which often works, or you have to maintain replicas of the data that you can query and do joins against. And so underpinning this is events, but that's a whole other talk. The point is that it is doable. It's very eminently doable, but it just adds this extra complexity. Testing is actually interesting. That can be more complex, because even though the individual pieces are easier to test, making sure that they all fit together and will actually work together adds some complexity. But the nice thing is there are testing patterns and testing frameworks that can help with that. And then, of course, deployment is more complicated. You have potentially tens or hundreds of services. Some organizations, like Uber, they have 2,000 services, which is, I think, roughly about the same number of developers, right? That's a heck of a lot of applications to have in production, right? So instead of uber.war, they've got 2,000 mini war files or whatever language they have, right? So from an operational point of view, that's a heck of a lot of services that need to be monitored and managed and so on. So the good thing is that, there are frameworks and products that help with that considerably. Good time to mention Cloud Foundry, right? And that's actually my sort of interest in microservices relates back to when I was doing stuff with Cloud Foundry, because there's sort of this synergistic relationship between the two. And then, of course, there's Docker alternatives as well, Kubernetes and so on. So the good thing is we can help. And interestingly, it's like your monolith will just get more and more complex, and so you're really, it will never get better. Whereas the nice thing is, even though microservices have this complexity, there are ways of managing that complexity and making it, so we're basically making it manageable. Frameworks, techniques, patterns, infrastructure, software, and so on. Another challenge is, before, if you had a feature that spanned different modules in your monolith, that was okay. You just kind of made the relevant code changes, committed them, tested it, deployed them, and that was an atomic step. Whereas now those changes could span multiple services. And that's a lot of planning, coordination between multiple teams. So you might have that anyway, but then the rollout relies on rolling out those updated services in sort of order of the dependencies. And so there's just a bit of complexity there. But there's plenty of examples out there showing how companies have overcome these limitations, but you should not sort of minimize the complexity. Your world, if you adopt microservices, will get more complicated. Okay, so that's microservices, both good and bad. Kind of now I want to sort of talk about the pattern language. So as I've said, there are trade-offs to be made, and so you really have to ask the question, are microservices a good fit for my application? And in reality, I talk to people who have said, we're using microservices, and it's like, well, why? And it's like, well, we need to go faster. And then it's like, do you do automated testing? Well, not really. So it turns out that before you even consider microservices, there's a whole bunch of prerequisites that you have to get in order. And it's possible that will address your problem anyway. But then if you do decide to use the microservice architecture, there's a whole bunch of different design issues the sort of specific design problems, design decisions that you have to make. And there will be a test on that slide in a minute. So anyway, so to help with this, that's why I've created the microservices pattern language. That's basically a collection of patterns that solve architectural design, development, and operational issues. So a pattern, of course, is a reusable solution to a problem that occurs within a particular context. And it was popularized by the Gang of Four book. That was a collection of object-oriented design patterns that came out in like 1994, 1995. Strategy, bridge, adapter, template, etc. But the concept of a pattern is much more general than that. And it provides a really, really powerful way of expressing the trade-offs associated with a particular approach, or particular technology, or a particular architectural approach, or design approach, and so on. So patterns tend to have this kind of structure. Obviously, they have a name. They have a context that describes the situation within which you're trying to solve a problem. Different situation could require an entirely different solution. You know, if you're building a small application, well, maybe you shouldn't use the microservice architecture, but if you're developing a large complex one, then perhaps you should. Obviously, there's the problem that you're trying to solve. There's the forces. Those are the issues that you're trying to address. There's obviously the solution itself, and then there's the resulting context, which is really powerful. Not only are you forced to describe the benefits, which is what we tend to focus on, right? Technology X is, or architecture pattern X is just awesome, but you're also forced to describe the drawbacks. So it injects objectivity into our discussion of technology, which remarkably is really lacking. You know, you go review a typical article in a magazine, website, or conference presentation. No one talks about the drawbacks of whatever it is they're advocating. Or very rarely. I mean, obviously not talking about if you do talk about the drawback of doing that is that it sort of doesn't get everyone quite as excited as just focusing on the benefits. So there are definitely trade-offs about discussing drawbacks. But it's really useful, and I think it helps a lot. And then you actually have to document the issues. And it's like, so if I apply the microservice architecture, you're now building a distributed system. And now you have all of these issues that you have to address: inter-process communication, service discovery, managing the gazillion services that you will inevitably end up with. Those are all issues that are consequences of applying this particular solution. But then to help with that, this pattern, the pattern format also forces you to describe the patterns that address those issues. So you're going to see when you look at the pattern language, you know, the microservice architecture is going to tell you, once you've applied this pattern, you now need to go consider applying all of these other patterns to address the issues that you've just created for yourself. There's also another kind of related pattern. Those are patterns that provide alternative solutions. So the write-up for the microservice architecture pattern will say, oh, by the way, you should go look at the monolithic architecture pattern, because maybe that is an alternative solution to the problem that you're solving, and it might be a better fit for you. So it's really nice. Patterns actually suggest sort of competitive patterns. So once again, it's adding sort of objectivity and kind of sort of honesty into the discussion. So then if we look at the microservice architecture, I mean, I've just kind of, the slide is too small to fit on a slide. You can see the context is developing a large complex application. Problem is sort of what's the runtime deployment architecture, various benefits, drawbacks, issues, points to the monolithic architecture as the alternative pattern. And then there are the successor patterns, the patterns that solve the problems that are introduced by this pattern, like service registry, API gateway, circuit breaker, so on and so forth. So that's the idea with this pattern language. And if you go to microservices.io, you will see a much more readable version of this. And due to my image map wizardry, you can even click on those patterns and navigate to the page. But there, you know, there's different categories of patterns, right? So there are what I'm calling the core patterns. That's the first decision you have to make. Should I use the microservice architecture? Should I use the monolithic architecture? There are decomposition patterns. If I'm going to use the microservice architecture, how do I decompose my system into services? And then if I do that, how do I maintain data consistency across them? How do I do querying? There are patterns around deployment, you know, containers, virtual machines, serverless. And then there's a whole bunch of communication patterns. ranging from should I use RPC, REST, or messaging, to how do I do service discovery, and so on. And then there's a bunch of observability patterns. How the heck do I figure out what is going on inside my system? And so on. So there are quite a few other categories as well. Testing, and UI patterns, and so on. So that's the pattern language. Go to microservices.io and check it out. So the whole point of this is to sort of act as a guide, right? Kind of helps you make these various architectural decisions and properly understand the trade-offs. So we sort of look at, the patterns in a bit more detail, right? So first thing is, like, what's the high-level architecture? Should I use a monolith, or should I use the microservice architecture? And there's sort of various goals or forces, right? Like, I want my system to be maintainable. I want it to be deployable. I want it to be testable, and I need it to be extensible as well. And those patterns have different trade-offs, right? The monolithic architecture is simpler in many ways, whereas the microservice architecture is more complex, but when your application is large, it can give you better maintainability, deployability, and testability. And then there are patterns for decomposition. And there's there's two ways to think about designing services. So coming at it from a business architecture perspective, you go talk to a business architect, they talk about these things called business capabilities, which are sort of, a function that a business does in order to get it, sort of deliver value to a customer. So that would be order taking, inventory management, deliveries, and so on. So you kind of basically describe services that conform to your business architecture. On the other hand, if you look at it from a domain-driven design perspective, it talks about subdomains. And so you can define services that implement subdomains. So those are two different kind of strategies which basically achieve the same thing. And then the other question is, it's like, how do you maintain data consistency? Each service has its own database. Its data is private. Think of like the fields of a class. And so it's like, how do I implement consistency across multiple databases without actually using two-phase commit? That is not a fashionable technology to use anymore. And then for that, you can either use, the effort for maintaining transactional consistency, you use the Saga pattern, which is basically an event-driven approach. And there's a few different ways of implementing that, including one called event sourcing. And then how do you do queries that need to join data across multiple services, given the fact that that data is private? And there's actually another pattern, which I just came up with a name of yesterday or the day before, API composition pattern. And that's where you basically gather data by just invoking the APIs of the services that own the data, and then you aggregate the results together. So new pattern coming there. Or you can use CQRS, command query responsibility segregation, that maintains denormalized replicated views by subscribing to the events that are being generated whenever data changes. Oh yeah.
Do you have one that lets you do kind of predicate pushdown sort of logic? Like if you have separate databases, you can't pull back like gigabytes of data efficiently. So
oh.
Yeah,
so the question is, do I do predicate pushdown? And my first thought was, golly, what's that? But yeah, it's actually, so the API-based querying works in a whole bunch of cases, but then as you said, there's always this risk of having to basically ship large data sets around the network and having to do basically these in-memory joins. I mean, in essence, what you end up if you kind of went down that path too far, you'd basically write a distributed query engine, right? Yeah, so you probably have better things to do with your time. And that's where CQRS comes in and just says, well, I'm going to subscribe to the events that are emitted by the services that own the data, and I'm going to maintain a view, sort of a copy of that data in an easily queryable pre-joined format to support that query. You know, so that's sort of a more practical approach. But yeah, there's a whole bunch of interesting issues there. You know, then, you know, another issue you have to make is decision you have to make is, how do my services communicate? What's actually really interesting is that there's so much emphasis on using REST today. You know, but the reality is that, well, one is something like gRPC actually has a whole bunch of benefits, right? So even within the sort of RPC pattern, you know, don't just look at REST, consider the alternatives. And also, sort of RPC pretty much only works for sort of query operations. If you need to do updates, then you actually have to use an event-driven or messaging-based infrastructure, because the properties of the messaging sort of broker, you know, at least once delivery is something that you're going to rely on heavily. So, you know, so we kind of focus, you know, there's so much discussion on sort of the wrong thing today, which is really interesting. And sort of following on from that, so to me, those are the key decisions that you have to make, right? Do I decompose my app? How do I decompose my app? How do I deal with the distributed data problems? And then how do I deal with the communication between the pieces that I've now created? And those are the key issues. And all of this other stuff, which is also another thing that people really focus on, like it's Docker this, Docker that, right? Or, for instance, you know, to a large extent, I mean, I sort of call this undifferentiated heavy lifting. It's important to get right, but it's just this standard thing that's the same pretty much for every application. Doesn't make it boring, doesn't, you know, it really is important to get it right. But, you know, it's almost like there's just standard off-the-shelf actual pieces of software that do this for you. Same's kind of true with messaging, but what I've talked about up until now involves a serious amount of thinking and designing and architecting, right? Whereas, you know, this stuff is just sort of off the shelf. So it's sort of like, you know, there's a whole bunch of cross-cutting concerns in a microservice architecture. You know, logging, externalized configuration, health checks, metrics, and so on. And actually Spring Boot, Spring Cloud, really, really useful microservice chassis. So if you're using Java and Spring, just build your applications on that. Other languages have their own microservices chassis. Deployment, right? You know, there's a whole bunch, you know, it's actually critical. It requires a high degree of automation. And the nice thing is, we've got choices, right, ranging from something like AWS or EC2 if you want to package your services up as virtual machines, to a Docker-based container approach, to a PaaS, or to this newfangled serverless. You know, there's a range of incredibly powerful options, each with their sort of respective trade-offs. I mean, I'm sort of a big fan of serverless because I think not having servers and just not having to worry about EC2 instances is just hugely useful, hugely powerful. But it's not for every part of your application. So it's like serverless when you can, and then pick something else for the things that can't be run as serverless. You also have to deal with discovery. You know, service A wants to call service B. How do you find the IP address? So you need a dynamic service discovery mechanism. So there's a bunch of patterns around that. And then lastly, monitoring, right? In a monolith, it's really simple. Request comes in, bounces around inside that one JVM and generates a bunch of logging, and yeah, it accesses the database. But in a microservice architecture, requests can bounce amongst all these different servers. And so figuring out what the heck is going on in your application is way more complicated. So you have to use patterns like distributed tracing, assign each request an ID, and then when a service handles that request, it generates log messages with that ID, and then you want to use a pattern like log aggregation to put all of those logs in a centralized place where they can be, where they're searchable. You need a health check UI, hence Spring Boot, Actuator. You need metrics, so that's part of Spring Boot. Code-to-Hell metrics are incredibly useful there, and you export them to a central metrics collection service like AWS CloudWatch or Prometheus, etc. And you want to track exceptions as well. Report them to a service that's dedicated to tracking exceptions. And you want to do audit logging. That's pretty standard stuff. But all of that will help you troubleshoot your application. So anyway, that's pretty much my talk. Thank you for listening. So in sort of summary, right? Monolithic architecture is a good choice for many applications, especially if they're small and simple. But if you find that you can't deliver software at the pace you need, and you're doing everything possible, like around testing and so on, you've got a large complex application, it's very likely that the microservice architecture will be a much better choice. It's not a silver bullet. There's a whole bunch of downsides, and so you need to carefully make the decision to use it. But then but the microservice pattern language can help you do that. And also, once you've decided to use it, it will help you sort of use it in the most effective and successful way. Thank you for listening, and if you want to know more, here's my contact info, learnmicroservices.io, and so on. So thanks.